Alright, now we come to part B, which is really one of the more complicated parts of a problem that I've seen throughout the years. But let's see what we have here. We're looking for the values of the constants m, b, and r, for which y equals mx plus b plus e to the rx is a solution to the differential equation. And over here I have the differential equation. Well, what that means is that this dy dx is really the derivative of y equals mx plus b plus e to the rx. So you could say that mx plus b plus e to the rx is also the integral of 3x plus 2y plus 1. But it's easiest to think about it. If you start with y, you take its derivative, you have to end up with 3x plus 2y plus 1. So let's actually go ahead and take that derivative. Well, the derivative of mx is just m, and since b is a constant, its derivative is 0, and the derivative of e to the rx is going to be r e to the rx by the chain rule. And furthermore, with the derivative we had the 2y in there. Well, if y is equal to mx plus b plus e to the rx, then we can also rewrite the derivative as 3x plus 2 times the quantity mx plus b plus e to the rx plus 1. And I can distribute that out, and then I can simplify that. And rewrite it so that I factor out the x, and I get 3 plus 2m times x plus 2b plus 1 plus 2e to the rx. And at this point we can kind of equate these two derivatives together. Well, you might see that r e to the rx is equal to 2e to the rx, and the constant m is equal to 2b plus 1. Now there's no x term in the original derivative, so we might be able to write it like 0 times x plus m. And when we do it this way, you can see that 3 plus 2m is equal to 0, so that m is equal to negative 3 halves. And then we have that 2b plus 1 on the right side is equal to m on the left. And so that means that m is equal to 2b plus 1, and plugging in negative 3 halves for m, we get negative 3 halves is equal to 2b plus 1. Subtracting 1 from both sides gives us negative 5 halves equals 2b. And finally that b is equal to negative 5 fourths. And finally we see that r e to the rx is the same as 2e to the rx. And this indicates that r has to equal 2. Now if you got this far, you're already doing pretty good. However, we're assuming here that r is got to equal 2. R could be r could be 0. Now in the event that r were equal to 0, the left side of the equation would just come out to be m, because you have 0 times x plus m plus r e to the rx, and the first term is 0, the last term would be 0. You'd end up with an m on the left hand side. Or we could still write that as 0 times x plus m, and plus 0 if we wanted. Then on the right side, because r is equal to 0, you would have, everything would be the same, but 2e to the rx would now just be 2 when r is equal to 0. And combining like terms, we'd get 2b plus 3. And so we're still going to get 3 plus 2m is equal to 0.